Hi, everyone. This will be a short overview of climate change, looking at the frequently asked questions document from the IPCC that we read for this week. Um, so I'll say a few words about what the IPCC is, and then also talk a bit about what climate is, what climate change is, what causes it. Um, Today's video is meant to be a rough overview of the basic science behind climate change and understanding what it is. Starting next week, we'll begin to look at some of the ethical issues associated with it. Um, so to start with, the IPCC, the acronym stands for the Intergovernmental Panel on Climate Change. This is a group of international scientists, so thousands of different individuals are involved. And they work under the UNFCCC, sometimes called the UNFCCC. That stands for the United Nations Framework Convention on Climate Change. So that's the basic international framework under which different countries through the United Nations try to address climate change. Some try harder than others. The various agreements that you hear about, so for example, the Paris Agreement from a couple years ago, also takes place under the UNFCCC. So countries come together and negotiate about what, if anything, to do regarding climate change. In order to do that, at least in theory, they need decent, reliable information about what climate change is, what it's doing, and what it's likely to do in the future in order to try and make decisions. This is assuming that countries are trying to be rational or ethical, which is not always the case, but assuming that you're trying to do that, you of course want to make your decisions based on the best available information. So to do that, the UNFCCC has sanctioned the IPCC, so again, the Intergovernmental Panel on Climate Change, to gather data, or actually gather the best published science that's available on topics related to climate change, and to gather them together into periodic reports. So every 4 years or so, roughly, it varies, the IPCC releases a huge report that tries to communicate the state of the art of science regarding climate change. So the IPCC doesn't conduct its own research, so it's not that kind of research institution. Rather, it brings together and organizes and vets research that's been done by others. So the way science works in the modern world, and climate science is no exception, is various researchers typically working at universities or research labs, sometimes government run, but often universities, most commonly, will conduct research on climate change. Various ways this might happen. So it can happen through observations of the natural world. So for example, taking temperature data, something that's been done for a fairly long time now. Or it can also involve computer modeling, trying to predict what climate change is likely to do in the future under different scenarios. Now, after scientists conduct this research, they seek to get it published. The way you do that is you submit the research in the form of a written paper, typically, with the accompanying data in some cases. You write that up and submit it to a what's called a peer-reviewed journal, science journal. So examples would be things like Nature, Science. Those are names of two prestigious scientific journals. There are various others. Some are more specialized, so dealing specifically with climate change. For example, climatic change is one. geophysical research letters, different journals like this. And when the research is submitted by these scientists, it's reviewed by other experts in the field. So the editors of the journal then send out the submitted paper to typically 2 experts, sometimes more, who review the work to see if it's up to standards. And there's various things that could happen at that point. So the work might be rejected for various reasons. So it might be that the reviewers find that the research is flawed in some way and shouldn't be published. Or it might be that the researchers decide that that this isn't sufficiently interesting to warrant publication, maybe because the other submitted work to the journal, and this would be a decision from the editor, but maybe the other submitted work to the journal is just of a higher quality, so it doesn't get published. The work could also be accepted and published, but it's very rare for it to be simply accepted outright. What happens more often is that the reviewers will provide feedback, so criticism, suggestions, and then the authors of the research will go back and revise. So make changes to how they present what they've done. It's possible, I don't think this happens very often because it would be a huge undertaking in many cases, but I might ask for different research to be done. So for example, in a computer modeling simulation, they might ask the authors to look at a scenario that they didn't originally model. And then the authors of the original research go back, they do that work, try to improve the paper and the research, resubmit it, and then typically the same reviewers if possible, and then the editor or editors of the journal decide whether the revised paper is worth publishing. So many papers every year do get published, but they have to go through this peer review process. So peer review meaning other experts in the field review your work and decide if it meets basic standards and is interesting, is worth publishing, or whether it ought to be rejected. So what the IPCC does, their job, is to look at all the published research that's come out, typically since their last report, which will be many hundreds, thousands of papers, right? So there's a lot out there. And the IPCC is composed of experts in the field, so people who themselves are submitting research to journals and so on, and who have a proven track record knowing what they're talking about. Will try and gather together this research to give the best overall picture that they can. And this takes a long time, a couple years, but eventually that work or that report is published, and it'll be all told hundreds of pages. The IPCC also produces a summary of that. It's called the Summary for Policymakers. No one expects that elected officials and decision makers are going to sit down and read 3,000 words, pages, 3,000 pages of dense discussion of climate change details. But hopefully they will read at least the Summary for Policymakers. That is a process that itself is interesting. We may talk about later. What goes into the summary is partly a political process. So the various countries will send representatives to a meeting, and they all have to agree on what ends up in the Summary for Policymakers. To be clear, the political representatives from these different countries, as part of the process, they can't insert anything they want into the Summary for Policymakers. They can't just make things up. So it has to be based on the recommendations of the scientific experts who write the full report. Now, the full report is completely independent of any political interference. But countries, of course, want a say in what goes into the summary because that's what most people will read, including the media. So there's, at these meetings, a lot of fights about what to include. So these countries effectively have veto power. Right? So the scientific team presents their summary and says, we think this is the best 20, 30-page picture we can give of the state of climate science right now. But countries go line by line and have to agree on everything that's in there before it gets published. So if one country doesn't like a certain line because it says something true that maybe makes them look bad in their eyes, or says something that they judge to be not good for their short-term economic interests, might try to get that line removed. Now, again, they can't add things, but they can argue that this should not appear in the report. And if they dig in their heels, in the summary, if they dig in their heels, they can effectively do that. So the summary for policymakers, because of that process, tends to be pretty watered down and will often look less dire than the full report, for the simple reason that, well, you need 120 countries, 130 countries to agree on what actually goes in to this, and that's hard to do. Easiest way to get agreement is to water things down and be more vague and so on. So the summary for policymakers isn't worthless. It's still worth reading, but it's important to keep that in mind. Now, in this class, I used to assign the summary for policymakers because it gives a decent overview of the state of climate change. But more recently, I've switched to using this FAQ document. So this also comes from the IPCC. And it's an educational document that's meant to explain what climate change is, what causes it, and what we can expect to happen in the future, depending on what we do in the near term. So a few things we're going to cover. So number one, trying to identify what climate is. So defining that. Number two, talking about what causes it. And then number three, looking at likely effects of climate change. So what can we expect to happen in the future? So first, what is climate? So the most basic definition that we can use, which is good enough for our purposes, is that climate is the average weather for some region. So the climate of some region is the average weather for that region over some period of time. So weather includes things like precipitation, temperature, humidity, wind patterns, things like that. We all know what weather is, but we also know weather can vary pretty extremely from week to week, day to day. But if you average that out over time, the extremes tend to balance out. And we can give a general description of what the weather typically is, right, in a certain region, at a certain season. That's the climate for that region, right? So examples might be some region might be typically have a climate that's hot and dry, right? Meaning that the temperature tends to be pretty high, and precipitation tends to be low, like a desert or something. So that doesn't mean that it's impossible for that region to have a rainy day, but that would be atypical, right? The weather might be rainy one day, but the climate for that region still is dry, right? Because on average, most of the time, it is dry. So of course, different regions can have different climate based on season. So some regions might have a dry season and a rainy season, right? So that's part of its climate, right? Part of the weather, average weather, right? The patterns that hold for that region are that, okay, the winter tends to be, say, dry. The summer tends to be wet with more precipitation. So we'll work with that. So climate is the average weather. Right, there's both global climate, so the average weather patterns across the globe. We can also look at it at a regional level. Also at a local level, although that's harder to model and predict. So that's climate. So climate change follows pretty straightforwardly, is changes to the average weather for some region. Right, so the climate of some place changes if the average weather patterns that hold in that region are different than they used to be. So that change could happen gradually, very slowly, or it could happen fairly quickly, as it is right now. Climate change is natural on Earth, so the climate has changed a lot over the 5 billion years that the Earth has existed. Well, at least since we've had a climate system, so less than 5 billion, 2 billion, or 3 billion, something like that. So in that sense, climate change is natural, but the climate change that we're seeing right now is not natural. It's caused by humans. So examples of natural climate change, right? Well, we have ice ages, right? So the temperature of some region that used to be fairly warm, well, some thousands of years in the future, due to an ice age, might be much colder now, right? Obviously, the climate has changed, but very gradually. So the current climate change that we're seeing global warming, right? So the Earth is becoming measurably hotter. Again, this is on average. So if you ever hear somebody say, depressingly, that, oh, well, climate change must not be real because today's pretty cold, right? So, it's some day in the spring, it's typically a warm day that time of year. Say it's unseasonably cold. Sometimes you hear people say, well, that doesn't fit with climate change. That is not too smart of an argument. And the reason is because what matters for climate change is, again, the average, right? So if you flip a coin 1,000 times in a row, it's going to even out pretty close to 50% heads, 50% tails, right? But if you look at just a string of 5 flips, right, you might get 5 tails in a row. And if you look at just those 5, you might conclude that, well, there's something wrong with the coin. It's weighted or something, right? It's designed to come up tails. But of course, that's not the case. If you test it out over 1,000 flips, you find out, oh no, it's even, and it was kind of a fluke that we had 5 or even 10, right? Which would be very unlikely. But we had a few flips right in a row that didn't fit with the overall pattern. That doesn't change the fact that the overall pattern is 50% heads, 50% tails. And what we know, and there's no question here because it's been directly measured and confirmed by various sources, scientists publishing the research in, again, peer-reviewed journals. We know that the Earth on average is warming up in just about every region. The Earth is significantly warmer today than it was 100 years ago, 50 years ago, 20 years ago. You might have some days that are not going to fit with that overall trend, but it doesn't matter, right? Because climate change cares about that overall trend. And we know that the Earth is warmer, significantly so. So climate change is changing in that respect. We've also measured, again, through scientific research that's been vetted through a peer review process. We know that other aspects of climate are changing. So, for example, precipitation patterns. So some regions getting more or less precipitation than they used to. These things are known. There's no question that the climate is changing. But you might ask, okay, well, what's the cause? And so that's our next question. I mentioned before that cause could be natural, right, in Earth's history, but right now that's been ruled out. The cause is very clearly greenhouse gas emissions from human beings, so human activity. So since the Industrial Revolution, human beings have emitted vast quantities of greenhouse gases into the atmosphere. We'll talk in a minute about what a greenhouse gas is, but the most common one is carbon dioxide or CO2. Another less common but more potent in its warming effect is methane. Humans have emitted a lot of this stuff as a byproduct of industrial activity. So the main one is burning fossil fuels. Fossil fuels include petroleum, coal, and natural gas. So through combustion of these fossil fuels, you can produce energy and electricity. That's fueled the Industrial Revolution, completely changed the Earth, human society, right? It's done a lot of good things for us, right? But a big problem is all these greenhouse gases that have been produced are warming the world and leading to climate change. So just as there's no question that climate is changing because it's directly observed, there is no question that greenhouse gases have been greatly increased through human activity. So there are naturally greenhouse gases in the atmosphere, so CO2 for example, but humans have added a lot to that. And again, this is something directly observed and measured. So from research stations around the world, a famous one is in Hawaii that's been doing it for decades, I believe, through air samples can directly measure the concentration of greenhouse gases, so CO2, for example, in the atmosphere. And it's gone up a lot, so nearly doubled since the Industrial Revolution began, so going back 150 years or so. So that's a really big, quick change for the Earth. So greenhouse gases, again, vary naturally throughout Earth's history. Sometimes we have more, sometimes we have less. But typically it's very gradual and takes a long time. So the changes we've seen just in the past century or even just the past 50 years are extremely fast in terms of how much extra CO2 and other greenhouse gases now reside in the atmosphere. So we know those things. We know that climate is changing. We know that greenhouse gases have been greatly increased. We know the reason for that is human activity, typically or primarily burning fossil fuels, but also some other causes like deforestation, which also releases carbon dioxide in the atmosphere. But the main one is fossil fuel combustion. So the next question is, why would this be the case? Why would increasing greenhouse gas concentrations in the atmosphere, why would that lead to climate change? So here we have to talk about the greenhouse effect. So the greenhouse effect is a well understood process whereby the planet captures incoming energy from the sun, so solar radiation, and warms up as a result. So the metaphor with a greenhouse, so you're growing plants in a greenhouse, you have the plastic or glass transparent roof and walls. You have plants growing inside, sunlight comes through. When that energy makes contact with the ground or the plants themselves or whatever it bumps into in there, changes the properties of that energy, so the wavelength changes. And that energy is less likely to be reflected back out of the greenhouse. Right? So some of it does, but the net result is that it's warmer inside the greenhouse without any artificial heating. It's warmer in there than it is outside because some fraction of that incoming sunlight, right, that energy, is being captured. And as a result, it warms up the air within the atmosphere within the greenhouse. So this is a well understood process. The same thing happens with Earth as a whole. So we have an atmosphere. One property of so-called greenhouse gases is that they tend to absorb some of this energy from the sun. So you have energy from the sun. Some of it hits the Earth. Much of that bounces off back into space, gets reflected, but some of it gets absorbed. The way this happens is through the greenhouse effect. So sunlight bounces off clouds or the Earth's surface, changes the properties of that energy, so the wavelength. And these greenhouse gases have the property of tending to absorb some of that energy. We're not going to go into the details of, in this class, of exactly how the physics of this works, but if you're interested, you can find information about that. Some of it's in the IPCC FAQ we read. For our purposes, it's good enough to understand that those greenhouse gases absorb some fraction of that energy from the sun. Now, this is a natural process. It's a good thing because if we didn't have a greenhouse effect, then life on this planet would not be possible. So it would be a very cold place, very inhospitable to life. So it's good for us if you like life and think it's a good thing that there are living species on Earth. It's a good thing that we have a greenhouse effect, right? Because it makes it warm enough for life to actually get by. The problem is if you intensify that greenhouse effect by adding greater quantities of greenhouse gases to the atmosphere, you also intensify the warming that the Earth experiences. And at some point, that can become very inhospitable to life. So, for example, the planet Venus is thought to have had what's called a runaway greenhouse effect at some point in its past. Venus is not a nice place to live, right now at least, at the surface at least, as it's very hot, right, has a very strong greenhouse effect, and you couldn't survive there, right? So it's possible, hopefully it doesn't happen, but it's possible that someday Earth could resemble Venus. Right? If the greenhouse effect continues to strengthen, then over time, it'd take quite a while, but over time, you could make this a very, very hot place to live, and then ultimately a place that you couldn't live. So that depends on the quantity of greenhouse gases in the atmosphere. The more you add, the stronger the warming effect. Right? So think of it as a more effective greenhouse. Right? At some point, you might make the greenhouse so hot that the plants inside won't be able to survive because they don't like that heat. Right? There's a certain comfort zone that in which they can survive. So same with humans and other species. Okay, so the greenhouse effect has been understood for a long time, going back to the 19th century. It's been studied a lot. What the science behind the greenhouse effect would predict is that if you add vast quantities of CO2 and other greenhouse gases to the atmosphere, then you would expect to observe a significant warming of the Earth as a result. That is, in fact, what we observe, right? So we're running that experiment right now, unintentionally, right? But we've added so much CO2 to the atmosphere that we'd expect to see a significant warming, and that is what we measure, right? Now, if we were adding vast quantities of greenhouse gases to the atmosphere, which we are, and we didn't observe warming as a result, that would be very surprising. And then scientists would have to go back and reconsider, what does the greenhouse effect, is it really a good hypothesis? Does it explain things well? Is there something else going on that interferes with it? But that's not the case here. We see happening on Earth exactly what would be expected in general, warming, as a result of increasing greenhouse gas concentrations. So all this taken together is a kind of argument, a very strong one, for why climate change is in fact human caused. It's because the natural processes are understood. The science makes a prediction about what would happen if we ran a certain experiment, in this case adding CO2 and other greenhouse gases, predicts we'd see warming. That is indeed what we see as a result of humans adding these greenhouse gases. In most of the world, climate change isn't questioned, right? Virtually every country that's part of the UNFCCC, which is every country on Earth, is on board with the basic science and says, yes, of course, right? It's clear that climate change is happening, that it's human caused, and as we're going to talk about in a minute, that it promises to bring some pretty harmful effects for human beings and other species. The context in the United States is very weird by comparison. So this is perhaps changing. But over the last a decade or two, there's been a lot of effort to try and downplay climate change, even to question it outright, or to question whether it's caused by humans. And that's, of course, for political reasons, and we won't get into the politics in this class. But from an educational point of view, I'm obligated to tell you that that is all nonsense. And there is no good reason to take skepticism about climate change seriously. So the actual scientists are the ones you want to pay attention to. And they are in a very clear consensus, right? The thousands of experts who have studied this for a long time and who have shown their work through peer review are very clear and in agreement that climate change is real and that it's human caused. So there's no real question about that. But due to various efforts, some people in the United States, again, it's a very strange situation here, but some people do still doubt it. But they're mistaken. Again, in no other major country in the world will you find a serious mainstream political party that denies that climate change is real and that it's a big problem. Right? Now, just because one country, in this case the US, is the outlier, that doesn't necessarily mean that they're wrong, right? It might be, hey, maybe we're the only ones who are right and everyone else got it wrong. It's possible. But to figure that out, you want to look at the evidence. And the evidence is now very clearly climate change is a real thing and caused by humans. All right, so the last thing we need to touch on here is what are some of the likely impacts of climate change, right? So yes, the Earth is warming. Yes, it's as a result of human activity. The IPCC, through organizing the other research done over the past decades, it's very clear that we can expect significant warming in the future, depending on how much we continue to emit, right? So if we cut emissions, the warming might be kept fairly moderate. That'll be tough to do. If we don't do anything, we could look at very dangerous changes in temperature. So that's, we don't know what's going to happen in the future because it depends upon our own choices. And also, it's hard to predict the future even if you know exactly what we're going to choose. But we might ask, well, why should we care about this, right? So the Earth is, say, a few degrees warmer on average. Why is that a problem? So as you know from reading the FAQ, some of the expected impacts of climate change are, for example, sea level rise is a big one. So again, this is something that is predicted, that as climate changes, if the Earth gets warmer, you expect that sea levels will rise. And in fact, we do observe that, right? Again, something that's directly measured through satellites and other means. So why is sea level rising? Well, two main causes. So one is melting ice, right? So ice sheets, for example, in Greenland and Antarctica, other places too, right? Well, that solid water, ice, melts, turns into liquid water, and adds to the oceans, right? You might think, well, the ocean is a big place. How could it make such a big difference? Those ice sheets are also massive. And if you melt them significantly, that's adding huge quantities of liquid water to the world's oceans, right? And that water has to go somewhere, and it's going to go up. Another cause of sea level rise, one that's maybe less obvious, is that hotter water, warmer water, takes up more volume, right? So this is known as thermal expansion. So ocean temperatures are increasing for the same reason that air temperatures are increasing, right? We have a hotter planet, so more energy. So that more energetic water will spread out a little bit more, right? So the molecules get farther apart. And again, you might think, how could this make such a big difference? Well, when you're talking about that many molecules, right, around the Earth's oceans, that adds up to a significant amount. So sea level rise is a problem because it threatens human populations, infrastructure, and also non-humans. Let's just focus on humans for now. Human populations and infrastructure along coastlines, right, which is where a lot of people tend to live. So, for example, New York City, very likely parts of it will be underwater in the future, right? So parts of Brooklyn, for example, just won't be able to live there unless humans engage in some pretty serious and expensive infrastructure. So building seawalls, for example, right? So maybe in the future, Manhattan will look like that. Maybe we decide that's worth saving. And huge seawalls are built, right? So that the ocean maybe over time rises by a meter, right? Which is a lot, right? Would lead to widespread flooding. You could invest a lot of money to try and keep that out through building walls, right? And, maintain them, so you don't want them to break. But best case scenario, that would be extremely expensive to adapt to, right? In some parts of the world, so for example, Bangladesh, it's a densely populated country. Many people live by the coastline. The land is very low lying, so as sea levels rise, that land becomes less viable, right? So people will have to move. Another aspect of sea level rise is related to the next potential impact, expected impact of climate change, which is an increase in extreme weather events. So of course, as the climate changes, the weather events also change in ways that are hard to predict. But some expected changes are, well, an increase perhaps in the frequency or the intensity of, say, hurricanes. So several years ago when Hurricane Sandy, and by the time it hit New York and Connecticut, New Jersey, wasn't a hurricane anymore, but just a very big damaging storm. Typically, those hurricanes head out to sea into the Atlantic Ocean, right? So they take a right turn before they make landfall this far north. But as climate changes and ocean temperatures are warmer, it's more likely that hurricanes will make landfall further north. Um, so, in the stable climate prior to the Industrial Revolution, it was very, very uncommon, and up until recently, extremely uncommon for hurricanes to hit Connecticut. But in the future, that might become normal. Now, obviously, hurricanes are very damaging, right? They kill people, cause a lot of economic damage. We have to spend a lot of money trying to clean that up, to mitigate the harm. That's money that we can't spend on other things like education or something. But it's especially harmful when regions that aren't used to this kind of thing begin to experience it. Right. So up until recently, it probably didn't make much sense for Connecticut to invest a lot of money in hurricane preparedness, right? As if something's unlikely to happen, it would be nice to be prepared for every possibility, but there are finite resources. So typically what you want to do is you want to invest your resources in preparing for events that are likely to occur, things that you're likely to need, rather than things that are extremely unlikely, right? Well, due to climate change, you have extreme weather events that are now occurring in places that used not to experience those. They're not prepared for those events, so it's much harder for them. And the resulting damage will often be far worse. Now, over time, humans can adapt to that, but that'll take some time, right? And until we figure out what we want to do, it may be the case that many states, countries will be caught off guard by extreme weather events that up until recently just didn't happen or were extremely unlikely for them. So other events, not just hurricanes, but things like droughts. So for example, in California, a couple of years ago, extremely bad drought and led to water shortages. So it had an impact on agriculture. And in the future, you can expect droughts like that to be more common, right? Again, potentially killing people, certainly causing a lot of economic damage. Flooding, things like this. I mentioned before that there's a connection between sea level rise and certain extreme weather events. So an example might be the following. With increased sea level, a country like Bangladesh is more at risk from hurricanes or cyclones, as they're known there. So storm surges are a part of one problem that you can experience from a hurricane, right? So due to the storm, it's like a very high tide, a surge of water that can flood a coastal community very quickly and cause all sorts of damage. Well, as sea level rises, the risk from that also goes up, right? So you have higher sea level. So places that were maybe not at risk from this before now are at risk from suffering due to a storm surge during an extreme weather event. So many of the problems of climate change will tend to be linked and can exacerbate one another. So things like extreme weather events, clearly harmful, things we'd like to avoid. Sea level rise. Also, another example of an extreme weather event would be heat waves. About 10 or 15 years ago in Europe, there was a really bad heat wave where many people died, especially the elderly, because there was a period of very hot temperatures that people weren't used to. And events like that are expected to happen sometimes, but they're expected to be more frequent as a result of climate change because we live in a hotter world. So again, you have a region where there's not much air conditioning because it's typically not needed, but you suddenly have 10 or 20 days of very high temperatures. People aren't prepared, and that can lead to a lot of health problems, right? And in the case of the European heat wave, many deaths as a result. Okay, so those are just some of the likely impacts that we can expect due to climate change. Overall, a hotter world, changing weather patterns as a result, including some extreme events, sea level rise. There are various other things that we can discuss. We will look at some other examples of effects of climate change when we discuss John Vroom's book in the coming weeks. But for now, I think that's a good place to stop. So things to remember from this. Number one, defining climate. So it's average weather, how it's different from weather. What climate change is. What's causing climate change right now, related to that, the greenhouse effect and how it works. Likely impacts of climate change and why they could be very harmful. And then also the basics of what the IPCC is, what its report is, and how it functions under the UNFCCC. So today's lecture has just been about looking at a very rough account of the basic science of climate change, what it is, how we know about it, what we can expect from it. Starting next week, we'll begin to look at some of the ethical issues, right? You can already imagine what some of those would be, but today we haven't touched on that at all. But that'll be our focus going forward. Before we can do that, though, we have to know what we're talking about. So what is climate? What is climate change? Got a decent understanding of that now, so we'll hit the ethical issues next time. All right, before I go, would you like to meet my dog? I assume you said yes. Annabelle. Annabelle, come. Just wants to say hi to you. Here she is. Hello. Say hi. Annabelle. All right, good dog. All right, thanks, guys. Bye.